In the first video, we looked at a function that was going to require a quotient rule, and then in the second video, we gave the quotient rule. So now let's bring those two things together, and let's say for the function g of x, which equaled, again, it was a quotient, 3x squared plus 7x minus 4, all over 4x plus 8, and we want to find g prime of x. You got a little bit of taste of this in the product rule, and with the quotient rule it just seems to be magnified, but your notation really is going to matter in terms of expressing that you're taking the quotient rule. So let's see if we can't apply this quotient rule using that little mnemonic that I gave you, low d high minus high d low over low squared. So I want to start off with low d high. Low being this denominator, 4x plus 8, d high, so the derivative of the numerator, so I want the derivative of 3x squared plus 7x minus 4, minus high d low, so high would be the numerator, which is going to be 3x squared plus 7x minus 4, times the derivative of low. So d low would be the derivative of 4x plus 8, and it is all over low squared, or 4x plus 8 quantity squared. There's your quotient rule expressed. So now if I take a look at what I need to do next, I've got a function I need to take the derivative of right here and right here, so let's do that, and then we'll start trying to simplify this particular function. So g prime of x is equal to, so I'm going to have 4x plus 8 times the derivative of 3x squared plus 7x minus 4. And I'm just looking at that particular trinomial. Derivative of 3x squared is 6x. Derivative of 7x is 7, and the derivative of minus 4 is 0. So there's the derivative of this piece right here, minus 3x squared plus 7x minus 4 times the derivative of 4x plus 8, which is just simply 4. And it's all over 4x plus 8 quantity squared. And we look at that and maybe say, hey, you could square out the denominator, and we could. I'm going to tell you for right now that's not going to be a necessary step. One of the things that can happen later on is we might want to take the derivative of the derivative. And so sometimes just kind of leaving it neatly packed like that is helpful. But what I can do is I can do a little bit of simplification of the numerator. So what I'm going to do is I'm going to multiply these binomials. I'm going to distribute over here. I've got a minus and then a 4. So I'm going to distribute minus 4 into this, and we'll just kind of collect some like terms and clean it up that way. So that's kind of the thought process right now. So g prime of x, if I distribute this, I get 24x squared. 4x times 7 is going to be plus 28x. 8 and 6, that's going to be 48x. And then 8 and 7 is going to be 56. And then again, for this next piece, what I want to do is I want to distribute negative 4. So that's going to be minus 12x squared, minus 28x. And then negative 4 times negative 4 is going to be plus 16. And this is all over 4x plus 8 quantity squared. And so the last thing that I want to do is I just want to go collect my like terms in the numerator. If I look at my x squareds, I've got 24 minus 12, so that's going to be 12x squareds. If I look at my x's, I've got 28, 48, and minus 28, so the only thing that I'll have left is this plus 48x. And then if I look at 56 and 16, that adds up to be 72, and that is all over 4x plus 8 quantity squared. And there's probably some simplification that we can do even further. It sure looks like everything has at least an even number in front of it. So there would be a GCF I'm sure we could factor out and reduce. But for right now, we really just want to focus on writing out the quotient rule, executing the quotient rule, and then just kind of cleaning it up to where we don't have a bunch of terms that we would want to collect. So this would be a perfectly acceptable answer for right now for g prime of x. Later on in calculus, we'll be doing things with these derivatives, and so we might simplify it or tailor it in a way that's going to set us up for success. For example, one of the things we'll do later on is we'll take the derivative and we'll be really interested in where it equals 0. And this is ready to go because we can set it equal to 0, which would just be where the numerator equals 0, and we could solve that quadratic equation pretty easily. So this right now is good enough for now. When we get to the parts of this class where we're using derivative, that's where we'll maybe focus on simplifying it in a way that's going to be conducive to whatever we're trying to do at that moment. But for right now, this is good enough for g prime of x.